Greetings class. This is another session of basic calculus. We are in quarter 3, week 6. Okay, our lesson 1 is about intermediate value theorem or IVT. IVT states that if a function f of x is continuous over a closed interval a comma b, then for every value k between f of a and f of b, there is a value c on interval a comma b such that f of c is equals to k. Kung makikita nyo yung graph na ito, sabi dito na if every k value, ito ano yung k, in between f of a and f of b, there is a corresponding c value in between intervals a and b. Kung nasa gitna ang value of k, ito, syempre dapat ang c value na equivalent niya ay nasa gitna din ng intervals a and b. Hindi pwede na ang value of c goes beyond intervals a and b. To give you an example, consider the function f of x is equal to 2x minus 5. By intermediate value theorem, there is a c on intervals 1, 5 such that f of c is equals to 1/2. First step is to evaluate using the endpoints 1, 5, 1 and 5, no? Okay. So let's solve. Gagamitin natin yung function, no? F of x is equals to 2x minus 5 and then we substitute the endpoints 1 and 5. Okay? So yung sa 1, we substitute 1, 2x. So f of 1 is equals to negative 3. No? Next for 5, we substitute 5 to x. So f of 5 is equals to 5. Now we examine if the value of f of c is equals to 1/2 is in between negative 3 and 5. Yun nakuha natin. So yes, 1/2, no? 1/2 is in between negative 3 and positive 5. Then, therefore, IVT holds true for this example. That is for step number 1. Sa step number 2, get the value of c from our original function. Yun ang gagamitin natin, which is ito, no? F of x equals to 2x minus 5. Ang gagawin lang natin, we change x to c, no? And then we substitute the 1/2 to sa f of c. So we rearrange lang, no? Dito natin lagay yung 2c minus 5 is equals to what? 1/2. And then we solve for the value of c. C therefore is 11 over 4 or that is 2.75. Okay, the question is 2.75 or 11 over 4 an element of the closed interval 1 and 5? Yes, indeed, no? 11 over 4 or 2.75 is an element of the closed interval 1 and 5. Next theorem is the extreme value theorem or the EVT. If a function f of x is continuous over a closed interval a comma b, then f of x is guaranteed to reach a maximum and a minimum on a comma b. Or the extreme values maximum and minimum of f always exist, and they occur either at the endpoints or the critical points of f. Take note that the critical point must be, or the critical points must be included or within the interval a comma b, which are the endpoints. So yung interval a comma b, ang tawag dito ay endpoints. Kung wala sa interval a comma b, it is not considered a critical point. The derivative at that particular point is equal to 0 or f prime of x is equals to 0. We take the derivative of the function and equate it to 0. Then we get the maximum and the minimum points. Again, the function f must be continuous on an interval like an IVT. So there are 4 steps in evaluating a function by EVT. First, find the derivative of the given function and equate it to 0. The value of c when f prime of x is equals to 0 are called the critical points of the function. And then number 3, get the functional values at the endpoints and at the critical points. Number 4, compare the values. We have an example here. Find the extrema or the extreme points or extreme values maximum and minimum of the function f of x is equals to negative 2x to the fourth plus 4x squared over a closed interval negative 1, 1. So ganito yung gagawin natin, no? Step by step. Step 1, we have the derivative or f prime of x. So we take the derivative of this function. Negative 2 times 4 is negative 8. And then 4 minus 3 will give us x to the third power. And then yung pangalawa, we have 2 times 4, that is 8. And then 2 minus 1 will give us x. For the second step, or letter B, we equate it to 0. So negative 8x to the third plus 8x is equals to 0. And then we solve for the value of x. Meron itong common factor, which is negative 8x. And then we can further factor this one out. Now we can get the value of x. So for the first one, this one, no, negative 8x and equate it to 0. So x is equals to 0 divided by negative 8. X is equals to 0. Ito naman, second one is x minus 1. We equate it to 0. So x, negative 1 to the other side will give you x is equals to 1. For this one, we equate it to x. X plus 1 is equals to 0. And then positive 1 to the other side will give us negative 1. Kaya x is equals to negative 1. So we have 3 critical points. X equals to 0, x equals to positive 1, and x is equals to negative 1. Now we determine if the critical points, these 3, is within the closed interval a and b, which is negative 1, 1. We notice that these 3 critical points is included in the closed interval negative 1, 1. For letter C, for the third step, we create a table. So we have 2 rows, x and f of x. And then we list the critical points that is included in the closed interval, negative 1, 1, which is, sabi nga natin, kasama yung 0, and then kasama din yung positive 1, and then yung negative 1. And then we substitute the value of x doon sa original function, which is this one. We substitute the value of negative 1 to the original function, we will get positive 2. We substitute 0 to the original function, we will get 0. And when we substitute 1 to the original function, we will get positive 2. So these 3 are called functional values. And then for letter D, for comparing the values, we just make a conclusion. Titingnan natin dito yung maximum point. The maximum point is at 2, no? Itong dalawa, 2. So ang kanyang coordinates is negative 1 and 2 and positive 1 and 2. And for the minimum point, o yung pinakamababa, which is 0 and 0. Now we proceed to lesson 2, optimization problems. Optimization problem is maximizing or minimizing function relative to some set, often representing a range of choices available in a certain situation. To solve the optimization problem, you may follow 5 steps. First is you draw a diagram if possible, and then number 2, introduce the variables. Number 3, find an equation relating to the variables. Number 4, find a maximum or a minimum function of one variable. And number 5, look for the critical points to locate the local extrema. Sa module nyo, meron tayong isang example. No? Sabi dito, a farmer has 600 feet of fencing and wants to create a rectangular field along a river. He needs no fence along the river itself. What are the dimensions of the field that has the largest area? Sabi dito, no, ang isang magsasaka, gusto daw niyang bakuran yung malapit sa isang riverbank. Pero yung side na to na in front of the river, wala siyang bakod. So, he has 600 feet of fencing. Ngayon, kailangan niya makuha yung area which is covered nung bakod. Okay, solution here, first is we derive the equation 600 is equals to L plus 2W. Ito ay galing sa perimeter ng rectangle which is 2L plus 2W or 2 length plus 2 width. Since sabi nga natin dito, wala tayong fencing sa banda rito, no, sa malapit sa riverbank. So we consider just only one length. And then perimeter, sabi nga natin, he has 600 feet is equals to L plus 2W. Kaya ganito yung ating nakuha. And then for the maximization function, kasi kaya maximization, getting the largest or the maximum area, we will use the area of the rectangle, which is A is equals to length times width. Now, to solve, gagamitin natin itong 600 is equals to L plus 2W, and then we equate it to L, no? In terms of L, and then we substitute it to the maximization function. Kaya ito yung ating nakuha. Now, we are solving for W. Pero bago yon, sabi nga natin, next step is to get the derivative of this function and then equating it to 0. So, getting the derivative of 600W will give us 600. Ito yon. And then, the derivative of negative 2W squared is negative 2 times 2 is negative 4. And then, we have the exponent 2 minus 1, maging 1 yan. Or W lang. And then equate it to 0. 600 minus 4W is equals to 0. And we can now solve for W. And the answer is, the width is 150 feet. And then we substitute the width or W back to the equation. No? This one. Pag sinubstitute natin yung 150 to W, ang makukuha naman natin is yung kanyang length. The length is equal to 300 feet. Now we get the width as 100 feet and the length as 300 feet, i-substitute natin siya dun sa maximization function para makuha natin yung largest area. So, 300 times 150 will give us 45,000 square feet. Now, for our lesson 3, we have the chain rule of differentiation. We have two formulas here for two functions, f of x and g of x, and they are both differentiable. So the first one tells us that to get the derivative of f of x, we take the derivative of the first function, this one, and multiply it to the derivative of the second function or the nested function. For number 2, same is true for number 2. Sa 1, pares lang yan. Ang ginawa lang is yung g of x ay ginawang u for simplicity's sake. To better understand the topic, mag-proceed tayo sa mga examples. Example number 1. F of x is equals to sine x squared. So, applying chain rule, sabi nga natin dito, ang chain rule ay ina-apply sa mga composite functions. Pag sinabing composite functions, we have a function nested inside another function. So, sinabi natin nested, nakapaloob. Like for example here, yung x squared is called the nested function na nakapaloob sa sine. Sabi nga natin, ang formula nito is we get the derivative of the outer function multiplied by the derivative of the inner function. So, derivative of sine x squared with respect to x is equals to derivative of the first function. The derivative of sine is cosine. So, cosine, and then just copy the inner function which is x squared. And then multiplied by the derivative of the nested function, yung function na nasa loob, which is x squared. Ang derivative niya is 2x, 2 minus 1 is 1, or 2x. Now, this is our final answer na. Okay, example number 2. Let's say we have f of x is equals to quantity 4 minus 3x squared raised to 400. Okay, sabi nga natin, to get its derivative using chain rule is the first function. The derivative of the first function times the derivative of the nested function or the second function. So, the derivative of the inner function is we bring down 400, di ba? And then 400 minus 1 is 399. Yung nested function, kokopyahin lang natin yan. Multiplied by the derivative of the nested function, itong inner function na 4 minus 3x squared. So, the derivative of 4 is 0. Wag na natin isulat. And then, yung derivative of negative 3x squared is negative 3 times 2. We have negative 6. And then, x squared, yung 2 minus 1 is 1. So, we have negative 6x raised to the 1 power or x na lang. And then, we simplify combining terms. So, negative 6x times 400 will give us negative 2,400x. And then, we just copy the remaining function, 4 minus 3x squared raised to 399. So, this is our final answer. For our last example na makikita sa ating module, we apply chain rule to f of x equals to 3x squared minus 2x plus 4 raised to 2. So, we have a nested function, itong nasa loob. And then, we have the first function that is raised to 2. Okay, we get the derivative. The derivative of the first function is you bring down 2, then copy the nested function. Then 2 minus 1 is 1. So, wag nyo na lang isulat. Multiplied by the nested function, the derivative of the nested function. 3x squared is 2 times 3. We have 6x minus negative 2. And then the derivative of plus 4, the derivative of a constant is 0. Now, we distribute 2 to the polynomial. We have 6x squared minus 4x plus 8 multiplied by 6x minus 2. Now, we multiply. We have 6x squared times 6x will give us 36x cubed. Then, negative 4x times positive 6x will give us negative 24x squared. Then, we have 8 times 6x will give us positive 48x. And then, negative 2 times 6x squared will give us negative 12x squared. Negative 2 times negative 4x will give us positive 8x. And then lastly, negative 2 times 8 will give us negative 16. Combining like terms, 36x cubed, negative 24 minus negative 12 is negative 36x squared. Then, positive 48x plus 8x will give us positive 56x. And then, we have the constant negative 16. So, this is our final answer. So, this ends our discussion for week 6. Don't forget to like the video, subscribe to my channel, and always keep safe. God bless you all, and thank you very much.